Hello everyone, and welcome to this video titled Regression and Correlation Analysis. If you are new here, please do not forget to hit the subscribe button and click on the notification bell so you'll be the first to get notified when I drop a new video. Without any hesitation, let's move on. So, regression. Regression can be seen as a widely used statistical method that is used to show the relationship between independent and dependent variables. So the independent variable is denoted with x and the dependent variable is denoted by y. X is our independent variable while y is our dependent variable. So what regression is all about is looking at the relationship between two variables. Let's take consumption as one of these variables. What you should ask yourself now is, what are those factors, what are those functions of consumption, those factors that you should consider before going for consumption, before consuming any goods. First of all, you should consider your income. Then you can also consider if you're on a diet. Some people are watching their weight, so they consider their diet. So before you consume, you will determine your income and you can also determine your diet. So consumption here is depending. So it's the dependent variable. Is the dependent variable and is denoted by y. While this income is our independent variable, is standing on its own, is independent and is denoted by x. So regression is all about looking at the relationship between the independent variable and the dependent variable. So there are types of regression. There are two types of regression. Number one, we have the simple linear regression. And then we have the multiple regression. Now, in simple linear regression, we look for the relationship between just one dependent variable and one independent variable. While in multiple regression, we look for the relationship between one dependent variable and more than one independent variable. Income and diet are not the only functions of consumption. There are other factors that affect consumption. So in multiple regression, we consider more than one factor that can affect the dependent variable. So our formula for simple regression is, let me write it down here. For simple regression, we have y equal to a plus bx, where y is our dependent variable, x is our independent variable, a is our intercept, and b is our slope or coefficient of x. Let me put that down here. Where y is our dependent variable, x is our independent variable, independent variable. Our a is our intercept, b is our slope or coefficient of x, So there's also what we call the MPC and the MPS. Our MPC is marginal propensity of consumption. Then that's our MPC. Then our MPS is marginal propensity of satisfaction. Our marginal propensity of consumption here is our A, which is the amount of commodity we've consumed. Then our marginal propensity of satisfaction is our B, that is the satisfaction derived from the commodity. Then there is also the formula can further be written as this same formula can further be written instead of y equal to a plus bx. It can also be written as y equal to beta naught plus beta 1 x. The beta is spelled beta, beta. It's a Greek word, beta. So looking at this, you see our y is still there, our intercept is the same thing as beta naught, our slope or coefficient of x is still the same thing as beta 1. Now, to consider the relationship between our dependent variable and our independent variable, we need to find our intercept and our slope. And now the formula for finding our intercept is a equals to summation y times summation x is to the power of 2 minus summation x times summation xy all over n open brackets summation x square inside minus summation x the square outside. Then to find our slope, the formula is n summation x y minus summation x times summation y all over n open bracket summation x square minus open another bracket summation x period square outside. So this is the formula for finding the intercept and the slope of a simple regression, a simple linear regression. What multiple regression now is all about is looking at the relationship between one dependent variable and multiple independent variables. Remember, the function of consumption, functions of consumption, we mention income, diet, and there are still more functions of consumption. So what regression now deals with is the relationship between one dependent variable and multiple independent variables. Our formula for multiple regression is we have our y, which is our dependent variable, equal to beta naught plus beta 1x plus beta 2x, and goes on and on and on till beta n. So you can see for multiple regression, it looks at the relationship between one dependent and then you have multiple independent. Multiple independent. So this is the difference between multiple regression and simple linear regression. Multiple regression, we look at the relationship between one dependent variable and more than one independent variable. But for simple linear regression, we look at just one dependent variable and one independent variable. There is also what we call the error term. For the formula for simple regression, the formula y equals to beta naught plus beta 1x. We also have our error term. For multiple regression, we also have the same error term. Now, what this error term represents is all those functions that have been omitted. So your error term can also be written as mu. So what it represents is all those omitted factors. Like for example, in simple linear regression, if what we have to find the relationship between consumption and income. Income now is not the only factor that can affect consumption. Remember we mentioned diet, and there are still other factors that can still affect consumption. So because we have omitted those factors, we now represent it with our error term here. The error term it can also be written as mu. Whether you write it as mu or you write it as error term like this, it's still the same thing. Both of them are still error term. But what you should know is that they both represent those factors that have been omitted. In multiple regression, we mentioned, let's take consumption as our dependent variable and our beta 1 as income and our beta 2 as diet. All those other, there are still lots of factors that can affect consumption that we have not included. So all those omitted factors now is now what brought about this error term. So error term now is representing omitted factors. That is just what the error term is all about. So I think we're done with regression. Now let's move into correlation and analysis. So correlation coefficient measures the extent and strength of a linear relationship between two variables. So we have our linear relationship, let's say equal to a plus bx. Do not try to use this with regression. Regression is your dependent variable the factors that affect your dependent variable. That is, x as an independent variable is a factor of y as a dependent variable. That is what regression is about. Now, correlation coefficient tries to measure whether if a change in x will cause a change in y. That is to say, if x changes, if x is moving upward, what happens to y? Would y also go upward, or would y go downward, or would y remain the way it is? That is what correlation tries to find out. So there are three types of correlation. We have the positive, the negative, and the no correlation. So number one, we have the positive correlation. I have the negative. And then we have no correlation. So, just as the name implies, correlation, they correlate. So, positive correlation now is when the two variables move in the same direction. That is to say, when a change in x causes a change in y to move in the same direction with x. For example, you use this phrase that says bird of the same feather flocks together. So we have we have x, two variables x and y, and both of them are moving upward. And if eventually x changes and started going down all of a sudden, if x started going down all of a sudden, then y will also start going down too all of a sudden. Both of them will move in the same direction. That is positive correlation. Then negative correlation now. When one variable changes and start moving up, and the other variable changes in the opposite direction. So if x is moving upward, then y would be moving downward. This is a negative correlation. X is moving upward, that y is moving downward. This is a negative correlation. Then a no correlation is when x doesn't cause a change in y at all, and y does not cause a change in x at all. They are not related in any way. So if x is moving up, y could be moving side. If x is moving downward, y could be moving in. Their directions are not even correlating. They are not moving in the same direction, and they are not moving in the opposite direction. They are just moving differently. They have no correlation. That is what no correlation is all about. What you also know about correlation is that correlation ranges from -1 to 1. That is, correlation ranges from -1 to +1. So a correlation is either -1 or 1, or it is between -1 and +1. And the only thing that is between -1 and +1 is we have -1, we have 0, and then we have 1. So a correlation is said to be negative. It is therefore -1. This is a negative correlation. Negative correlation is -1. Then a positive correlation is 1. plus 1. And then when there is no correlation at all, we could say it's a zero correlation. There is no correlation, so it is 0. A correlation is denoted by R. R is how we denote a correlation. So if R is less than 0, then obviously R has to be minus 1. And so therefore R is equal to a negative correlation. But if R is greater than 0, then R is plus 1. Then it's said to be a positive correlation. Then if R now is equal to 0, then it's a no correlation, a zero correlation. So there are actually different methods of finding correlation coefficients, and on this video I'll be giving you two methods on finding the correlation coefficients. So the first method, we have the Spearman's rank correlation coefficient, and we have the Parsons product movement correlation coefficient. Methods of correlation coefficients. Method of correlation coefficients. Parsons product movement correlation coefficients. Parsons product movement correlation coefficient, PPMCC. And then we have Spearman's rank correlation coefficients. Parsons correlation coefficient is denoted with R, while Spearman's correlation coefficient is denoted with P. So the formula for Spearman's, so there are two formulas for Parsons products movement correlation coefficients, and the first formula is R equal to n summation x y minus summation x summation y all over the square root of open bracket n summation x raised to the power of 2 close bracket minus summation x, which is 2 raised to the power of 2 outside, minus open bracket n summation y raised to the power of 2 minus another bracket n summation of y close bracket 2 outside. So this is the first formula for Parsons product movement correlation, and the second formula is R equal to summation x 1 minus x bar open another bracket y 1 minus y bar all over the square root of summation x 1 minus x is the power of 2, and then summation y1 minus y bar is the power of 2. So for person's products, movement, collision coefficient, you either use this formula or you use this formula. So let me give you the formula for Spearman's rank correlation coefficient. Spearman's rank correlation coefficient. And the formula for Spearman's rank correlation coefficient is P equals to 1 minus 6 summation d1 is the power of 2 divided by n open bracket n is the power of 2 minus 1. Then you put everything in the bracket. So this is the formula for Spearman's rank correlation coefficient. So that will be all on this class. On the next video, we'll be solving problems related to simple regression using the formula. Then subsequently, we'll be solving problems related to multiple regression and correlation coefficients, also with the formula. If you are new here, please do not forget to subscribe and click on the notification bell so you won't miss more. Also, do not forget to like and make use of the comment section. Until next time.